Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 tonight's flight. We're going to be able to fly in Zurich, Switzerland, Germany, then coming back to the Zurich International Airport. Runway 1449, let's localize the landing zone. I'm now in the cockpit for the pre-takeoff preparation with the quality wings, Boeing 787-900 and Microsoft Flight Simulator, right? I'm going to start showing you the cockpit instruments that displays and the functions of the Boeing 787-900 Z aircraft. I'm going to start with the primary flight display that displays how the airspeed indicated. The airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10 handles and feet per minute, the steepness of the trigonometric angles in degrees can climb and descend. We have also the angle of attack, so you can climb and descend, the rate of climb and descend. We have also the we have the artificial horizon with the altitude indicator, the pitch ladder degrees and the bank angle degrees. We have the Lszh localizer, the instrument landing system, the radio frequency transmitters of the threshold antennas of the runways we use for takeoff and for landing that transmit the radio frequency. We have to align with the magnetic north pole heading when we take off and when we approach for landing. So we receive this radio frequency from the onboard antennas of the aircraft, and this is displayed in the localizer and the horizontal localizer and vertical glide slope. So we have a unique radio frequency for each runway and heading we use for each airport and runway, and the magnetic heading we use. So we have to tune this Lszh frequency. So you will see how we're gonna do that. We have also the Lszh localizer crossbars displayed in the primary flight display. We have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode and zero with the autopilot and the auto throttle, lateral and vertical navigation modes. We have also the HSI that displays the horizontal situation indicator, the magnetic heading and tracker, and we have the display of the flight plan. We're gonna create a flight plan later. You're gonna see here in the flight management computer, I'm gonna create a flight plan. I will input all the data, all the waypoints we need. So we'll select the departure airport and runway, and also the Cs, the southern instrument departure waypoints and fixes, and then the stars, the southern terminal arrival waypoints and fixes, so the destination airport and runway. We're gonna have a complete flight plan or a flight path route. You're gonna see how using this flight management computer, and so we can use the LNAV and the VNAV functions of the autopilot flight director system panel. When we engage that in the air, it will follow the flight plan we have created. So we can either fly manually or use the autopilot flight director system panel to fly the flight plan we're gonna create. We have also the navigation display that displays the horizontal and vertical profile of the aircraft as it flies, the GPS position of the aircraft, the magnetic north pole and the geographic north pole, the magnetic variation depending on where we are on the world. You can see the terrain weather reflections from the weather radar. You can see the terrain displayed with red, green, yellow and amber color indication depending on the distance the terrain is away or below you. And also we can see the lakes, the rivers and the sea with blue. So the distance and also the elevation, if it is higher or below you, it will show you over here. You can see in the navigation display we show us different codes over here. So we have the red, green, yellow. As you can see, the red right now is 4,900 and the amber is 016, 1,600. So if we look closer, you will see when we fly we're gonna have the terrain below us like this, and the distance. You can see the aircraft when it's flying. We're gonna have to fly through these waypoints, and also we select the flight plan area so you can see the terrain below in front of you, and also the horizontal profile and the vertical, also the distance in nautical miles over here, like 20 nautical miles away in front of us, and the altitude we're gonna be flying. It will show us how many thousands of hundreds of feet we're gonna be above the terrain. You can see also the airports here. You can see the Düsseldorf DDL airport over here is in front of us, like 60 nautical miles away. We have the 80 nautical miles away range. So we are here in the Zurich Lszh airport. You can see the aircraft position, 40 nautical miles to 80, 10, the distance and also the degrees. Over here the magnetic North Pole right now displayed versus the geographic North Pole. So we have the navigation display, also displays the terrain map with the airports. You can see the airports where they are located, the distance away from your aircraft. You can see in the airport that we have that we use for takeoff and for landing. You can see the runways and the taxiways we use, the runway length, and also the heading of the runway for takeoff and for landing. We have also in the navigation display the navigation aids, the road stations, NDFs and DBs, the waypoints, which are horizontal and vertical navigation fixes, and I'll leave the airspeed constraints. You're gonna select some waypoints from the flight management computer. You're gonna see how later when we create the flight plan. So they're gonna show us a purple line connecting the waypoints one by one. That is the flight plan. We have to follow the route of the aircraft using the autopilot or manually. So you see also we have the voltage, and we have also the display of other aircraft fly around an aircraft using the transponder. The ADSP and ADC transmitter receiver transmits our frequency to other aircraft in the air traffic controller and receives from other aircraft. It will make calculations with its computer. Using the radio frequency, it will calculate the other aircraft distance up to 40 nautical miles or 72 kilometers in bearing from our aircraft distance and heading. Also the altitude difference from our aircraft, how many hundreds and thousands of feet are above or below our aircraft. Also it will show us we can calculate whether the other aircraft climbs or descends with respect to our aircraft. We can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning if we have an incoming collision in the air from the TCA system, the Traffic Collision Advisory System. So we will make an avoidance maneuver in the air. Also in the ground, you can see the other aircraft in the taxiways and the runways. So we can see the aircraft from the TCA system, the Traffic Collision Advisory System, with a diamond shape in the navigation display, and also with an altitude indication of the altitude difference from aircraft plus or minus sign. So you will see later over here in the navigation display. We have also other display. We have the autopilot calibration system panel. We have the engines display. I have the flight controls of the aircraft. So I will show you how I control using the mouse pad here and the keyboard to input all the data I need in the autopilot, or also in the overhead panel to control the switches, the flight management computer, the horizontal trim stabilizer over here, and here the horizontal tail, and also the side stick I use here. So I have the Logitech Stream 3D that is identical to the Airbus side stick. So you can see we can climb and we can descend the aircraft. We use the yoke of the Boeing 787 for climb and descent. Also make turns to the right, turns to the left like this. Also the rudder pedals like this, make directional steering. The nozzle, the vertical rudder. So we climb and we descend, we make turns to the left and turns to the right. You can see the position of the control wheel is similar, it's same like the side stick deflection left and right. Deflection for making turns. Also climb descent. You see in the Airbus we have the autopilot disengage switch here, the side stick priority button and the push to talk button. Also I have some buttons over here. So we have also the thrust levers. Over here we can actuate the thrust control by the engines using the switch over here. So actuate the engine thrust over here. The πας έξω? Πού? Στο μαγαζί? Τι ξέχασες? Καλά, εντάξει. So we can increase and decrease the thrust over here. The percentage of the thrust, exhaust gas temperature, and two, you can see the indications are controlled by the pharex. When we move the thrust levers, we give a command to the full authority digital electronic control computers that control the engines functions of the Boeing 787 or other jetliner aircraft. So you can see the primary flight display that I was talking to you. You can see the airspeed indicated here, the airspeed tape, the airspeed selected from the autopilot, flight director system panel, the radio altitude above the ground level, the pitch ladder in degrees. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. Also the wings level of the aircraft. So we have the side slip indicator. You can see the turns when we're turning. It turns in the air, how many degrees, like 5, 10, 20, 30, 45 degrees, like this, left and right. Also the barometric altitude, the barometric pressure of the outside atmosphere over here. The vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute. So you see this needle moving up, 500, 1000, 1500, 2000, 3000, 6000 feet when we climb or when we descend. Also the barometric altitude, the target altitude, we see the flight director, the crossbars. This purple indication is what we have to follow from the flight management computer or the Ilsloc localizer. You can see 2 feet, it will show us -2. It will show us like 2500 feet above the ground when we fly, also here in the navigation display. So we can set the barometric pressure of the outside atmosphere over here. You see 29.92 inches of mercury right now, so we have the standard. We can increase and decrease. It will change the barometric altitude the aircraft is right now. It will show us different altitude. So now we have the correct altitude for these atmospheric conditions. So we set from here inches of mercury, 29.92 right now, or 1013 hectopascals. So we have also radio baro, the plan map menu, the range. So this sets the barometric pressure just before going to flight. Also in flight we can change that, 29.92 right now. We have also the flight mode annunciator. It gives us the autopilot and auto throttle, takeoff, ground, the HSI, of course the low situation indicator we use later, different indications. So here is for mainly the range, the plan, the menu. This for weather radar, traffic and terrain on the display. This for these displays here. That displays the map and the plan, the flight plan, and the other aircraft, the weather and the terrain. Also the aircraft when it's flying. So we have also other indications. We can see the system, CDU info, checklist, communication, navigation display, ACAS, engines, cancel, reject, left or right. We can expand the map, like in the other side we have a full map view. In the navigation display we have no engines. So we have here also the autopilot, flight director system panel, use later autopilot, engage and disengage switch over here. Autopilot disengage, the auto throttle left and right over here. Flight director on and off. The airspeed can change the airspeed like this, or the heading other switches, the altitude. So we'll set this later, the way we should be before flying. You can see we have 200 knots airspeed, 360 heading, 10,000 altitude, and the vertical speed is 0 right now over here. So we'll change the settings. We have our localizer, the approach, the flight director. So flight director is on. You can see the settings here. 200 knots is the target Airspeed 10,000 feet is the target altitude, and the heading 360 degrees. We have also the altitude, target altitude here, 10,000 feet. This is purple line. We'll change the values later, so we'll see different values. So I'll talk to you about the flight controls of the aircraft, how using the side stick. Also, you will see the horizontal tail trim stabilizer, how we can trim the horizontal tail of the aircraft of the Boeing 787 when we fly. So this is a fly-by-wire aircraft. Like the other Boeing aircraft and the Airbus aircraft, it has a flight control computers. So we can, when we make a side stick deflection in the Airbus or the yoke in the Boeing 787 or the 777, we give a command to the flight control computers in the air, depending on the mode the flight control computers is. So we have the normal, the alternate, and the direct mode of the flight control computers, like in the Airbus. Also the direct and the mechanical backup. In the Airbus we can make left and right turns, limited with the flight control computers in the normal mode, 2.8 G, where G is the acceleration of the Earth gravity. So we have 2.8 G left and right turns, or 67 degrees of side stick deflection with the side stick maintained in the Airbus. Also, we can climb 30 degrees or 1.5 G in the Airbus, or descend with the side stick deflected down minus 15 degrees or minus half G. We have other protections, like the alpha protection and the overspeed or the velocity loss selectable. So we have also the primary flight control computers here in the Boeing control flight controls when we fly. We have also the air data computer, flight control services, also later this system. We have the auto trim also for the horizontal tail, which acts automatically when we fly. It trims the aircraft in the Airbus, also in the Boeing aircraft. Especially in the Boeing, when we connect the autopilot to the director system panel, we use the autopilot and the autoflow. So you can see here we have the horizontal trim stabilizer like this. We can trim the horizontal tail of the aircraft when we fly, the flight controls. This is the control wheel of the Boeing 787. So you can see we have elevator trim, left click down, right click up like this. Look a little bit more further away, you will see the tag here. Elevator trim, left click down, right click up over here. So this is the elevator trim. We trim this way, we push this switch up, this way it trims the elevator up, it pitches the nose of the aircraft up when we fly, and this way we trim the elevator down and we pitch the nose down. This is the aerodynamic effect we get as we fly. So we balance the aircraft with that, without using the elevator force. So we have the autopilot also disengaged here. The head-up declarer could declare the flap speed. So you can see how many degrees you pitch up and pitch down. The stabilizer trim, 4 degrees nose up or nose down. The rudder trim, also the flaps position. The cabin pressurization, I will talk later about the other systems. So we have the landing gear, also extend and retract, alternate gear over here, lock override, the retract and extend, speeds and the auto brake here, rejected takeoff. You see RTO, auto brake RTO, off RTO, or auto brake 1, 2, 3 for landing. So we have here I'm showing you the horizontal tail trim stabilizer. You can see we can trim the elevator over here when we fly. Also we can move the elevator up and down for climb and for descent. So this is the yoke of the Boeing 787, the control column for the elevator and the control wheel for the ailerons and the spoilers, the rudder pedals also for the vertical tail, the rudder, and also for the nose wheel steering of the aircraft. We can control the forward nose wheel using either the tiller or the rudder pedals. So we climb with the descend, we make turns to the right, we make turns to the left. Also we have the horizontal trim stabilizer. We have the flaps position. The flaps are secondary flight controls. We can retract now or extend how many degrees for takeoff. You can see the flaps position over here, and here in the display, flaps fully extended. We have the speed brakes also, extend and retract, like these speed brakes. We have the horizontal cutoff switch for the horizontal trim stabilizer. Normal cutoff, the L2 and the R2. So I'll talk to you right now. We have the pit stream over here. The alternate channel of the flight control computers over here. So this way we pitch the elevator up again, and we pitch the elevator down. We trim the nose up. We pitch the nose up and we pitch the nose down. This is the pit stream, similar like in the Embraer aircraft or the CRJ. So this balances the tail of the aircraft again. Brakes on and off, parking brakes, fuel control for the left and right engine. For the horizontal trim stabilizer, this is the main concern right now. So if you have a failure in the Boeing aircraft of the hydraulic systems, over here you can see the left and the right engine driving, hydraulic and electric C1 and C2. We're gonna have the grade of the flight control computers mode from normal to alternate or direct. So we will have a malfunction. We'll lose the autopilot because we won't have the auto trim function. So this is for the Boeing aircraft, the Boeing 737. If we have a degrade of the flight control computers, we cannot use the auto trim. So we have to disconnect this horizontal trim stabilizer switch from normal over here to cut off. As you can see, we have this red guarded switch here. This is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 787. You open this red guarded switch from normal to cut off over here. As you can see, if you have failure of the hydraulics of the L2 or R2 that affects L2 or R2 from normal to cut off, you can read. So you disengage the horizontal trim stabilizer and you use only the alternate. You lose the automatic trimming and the autopilot function. So you have only the manual trim switch all the time. You can trim the elevator like this, elevator trim. You see, left click down, right click up, left click down. So we use only this manual or the alternate flight control computers channel over here in flight. Nose up and nose down, ground proximity, very high frequency satellite, ground proximity, weather radar. So we have also the navigation radios and the satellite weather radar, transponder, high frequency communications over here. We have also fire extinguishers, left and right engine, the transporter, the rudder trim. So we have a few things more to see here. So I'll show you now how to use the flight controls that I told you, how to control the flight controls using the side stick here, so we can climb and we can descend, or the yoke of the Boeing 787. So I will talk to you about the Newton's physics, aeronautical and aerospace engineering, and aerodynamics. We need to know for the air transfer pilot license or the commercial pilot license. We need to know aerodynamics, flight dynamics, the dynamics of flight, and some principles we use for flying an aircraft. So you can see here we have for airplanes like an airliner. So you can see we have the forward wings of the aircraft that hold the weight of the aircraft when we fly. The aircraft weight is divided over the surface area of the wings. also the propulsion from the jet engines that push the aircraft forward. The wings lift acts over the weight of the aircraft. So we have the physics vectors. So you can see the jet engines. We have turbofan turbojet engines. You can see we have the high pressure compressor and turbine in the back section of the engine, high pressure compressor and turbine, and high speed starter and shaft and spool. And also we have the front fan and the low pressure compressor and turbine of the turbofan turbojet and the low speed starter and shaft and spool. So we have also the combustion chamber over here, where is the turbine, high pressure turbine. We have the fuel flow from the top over here, the fuel lines. So we have the fuel tank, left and right wing fuel tank over here that feeds the engines, and the booster pumps from the tanks lines. So we have also the exhaust, the nozzles that propels the aircraft forward, the jet blast from the exhaust cone. We have the bypass air over here, because this turbofan turbojet engine has bypass air from the front fans and the thrust reverses. So we have also the wing and engine on the ice over here lines. So you can see we have the mean aerodynamic chord, 23% of the Mach, where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the center of pressure is moving back and forth in the top surface of the wings. When we fly the stall, also the airflow becomes detached when we fly from the top surface of the wings, and the wings stall over here. So we need to make when flying, we monitor here in the airspeed, the primary flight display. We can see the airspeed indicated over here. Just below the airspeed, we will see the stall speed with an amber and red warning indication. We need to avoid that. We need to overcome the stall speed and the angle of stall. So we push the yoke of the Boeing aircraft down, or the side stick of the Airbus, and we apply more thrust to make a stall avoidance maneuvers. So we have also here the mean aerodynamic chord. We have also is the center of gravity of the aircraft. It's the yawing axis. So the yawing axis makes turns left and right over here. So left and right turns, the yawing axis. You use the rudder to make yawing turns through the center of gravity of the aircraft over here. Also to balance the aircraft flight path. So we use the rudder pedals like this. You can see the rudder pedals over here. We have the rudder pedals. So we move left and right rudder. Also the directional steering, we can use the rudder pedals to control the forward nozzle. So it's the same for the Boeing or the Airbus aircraft. The rudder pedals function for the rudder, have it in the side stick. And also we have the forward nozzle over here steering. So when we are in the ground just before takeoff, we have forward nozzle steering, 76 degrees deflection left and right, which acts with the rudder pedals from 0 knots up to 45 knots. Up to 45 knots or 72 kilometers an hour, the rudder becomes aerodynamically effective over here. So from the computer automatically, the forward nozzle steering will decrease from 76 degrees left and right deflection to 7.6 degrees. It will be limited. So we have above 80 nautical miles an hour, above 45 knots, up to 80 nautical miles, we have 7.6 degrees together with the rudder. When we press the rudder pedals like this. So as we accelerate for takeoff above 80 knots or 144 kilometers an hour, the forward nozzle is locked to 0 position, 0 deflection from the computer automatically. We don't need to do nothing in either case. is automatic from the computer, and we have only the rudder aerodynamically effective above 144 kilometers an hour or 80 nautical miles per hour over here in takeoff. So in landing, when we land, we start with the rudder because we have higher airspeed, like 140, 150 knots, like 250 kilometers an hour. So it's the inverse. First we have the rudder, then the nozzle becomes active. Also sometimes the nozzle is active, like a small amount of deflection, like a half degree above 80 knots or 1 degree together with the rudder. It's a very small amount. So this is a rudder control. Also we have one more axis over here. It's the pitch axis, from wingtip to wingtip. We use the side stick deflection for climb descent, like this in the Airbus aircraft. You pull the weight up or you pull the weight down, very easy because fly by wire, you don't need to apply too much force on a side stick. Is controlled by wire. So we have by computer. So we have a climb and descent. Also in the Boeing we have the yoke back and forth. So this is the elevator for climb and descent, the pitch axis. Side stick back and forth in the Airbus is the yoke back and forth in the Boeing. Same flight control principle, no difference at all. You climb, you take the weight of the aircraft up, and you take the weight of the aircraft down with the Boeing or the Airbus, and you climb or you descend using the elevator of the horizontal tail of the aircraft over here, as you can see. So this is the horizontal tail. So we have one more axis, the longitudinal axis from nose to tail over here. Is the side stick left and right, is the roll axis, is the side stick left and right in the Airbus. So you can use over here, as you can see, we have an aircraft is coming for landing. We just spotted a Boeing 737, you can see, very nice. So we can use the side stick left and right in the Airbus, is the roll axis. It makes the ailerons and the spoilers in the Airbus aircraft to make a direction, a differential pressure between the left and the right wing, a differential lift, which makes the aircraft roll around this axis, the longitudinal axis. So in the Boeing also we have ailerons, spoilers. You can see ailerons, spoilers when we deflect over here, and also we have the flapper on in the Boeing aircraft, one more surface. So you can see the spoilers now extended, also the aileron here and here. So we have the flaps also over here, down here, extended. So this is the control axis of the aircraft. The aerodynamics we need to know, the flight dynamics for the air transport pilot license. So we use side stick left and right, ailerons and spoilers left and right, control wheel in the Boeing aircraft. Very easy, same function like in the Airbus. You can see it looks like a side stick actually when you make the turns, left and right turns. No difference at all. So we have the other aircraft, also the Embraer and the CRJ are similar to the Boeing with the control wheel and the control column, the yokes. So the yoke of the Boeing 787 fully explained. We're gonna see a couple more, one more view of the flight controls of the Boeing 787, then we go for starting up the engines and setting up the flight management computer. So you're gonna see the complete flight using the Boeing 787. So I'm gonna show you now this view of the flight controls. You can see again we have the computer here, the side stick, and the mouse pad over here. So I use this view over here. You will see One more view of the flight controls and the cockpit. Very easy, so we can see we can climb and we can descend using the side stick back and forth. In the Airbus is in the Boeing is the yoke back and forth. You can see both sides in the captain and the first officer in the Boeing aircraft are interconnected and move together. Also the rudder pedals, both in the aircraft in the Boeing and the Airbus are interconnected. But in the Boeing you have to use force in either side to override the other side. In the Airbus you just have to press the side stick priority or have dual input. So this is the only difference. Hope you like it. Also the thrust control over here, we can actuate the thrust and use the horizontal trim stabilizer. Trim the horizontal tail like this instead of pressing here this switch when I fly manually. So hope you like over here. So we climb with descent, make turns to the right, make turns to the left. So you can see also we climb it with descent, elevator up and down, side stick back and forth, no difference in the Boeing or the Airbus aircraft. Side stick deflection proportional to the yoke deflection, as you can see. Also the outside view, then we go for the rest. So we climb with descent, elevator, rudder, left and right turns, ailerons, spoilers like this, no difference. Hope you like over here my flight controls. I control the aircraft. So we go now for the rest of the systems and now the flight management computer over here. So we have all controls also. Forgot to mention we can use all controls in flight, elevator, aileron, spoilers and rudder to have coordinated flight. You will see also that. So we go now for the flight management computer and set up the flight plan. So we'll show you now how to use the flight management computer. We'll input all the data we need for this flight, create a flight plan that is going to be used also from the autopilot flight director system panel. We're going to use the takeoff speed, V1, V0 to V2, the flaps for takeoff, the horizontal trim stabilizer, also the center of gravity of the aircraft, the fuel on board and the gross weight for takeoff, and the reserve fuel also, the altitude, the cruise altitude we're going to be flying, the speeds of flight, the rate of climb descent. So we're going to have a flight plan. You can see I can use this and my keyboard to input the data here from the flight management computer. So you see here we have the mouse pad also to control the functions. We need the keyboard, the screen, the CDU, control display unit, so we can use the most position, performance, takeoff, approach, navigation data, loaded traffic control. So I'm gonna show you this view now over here. This view over here, control quadrant. So you can see this view of the cockpit also, the autopilot here, the screens. So we start identity, position, performance, takeoff, approach, announce status, flight plan. So we have the identity is a Boeing 787, the NX engine installed, the air cycle. The position we can align the inertial reference system, the laser gyroscopes that align the aircraft with the magnetic north pole and geographic north pole, the longitude of the latitude of the aircraft. So we have position, performance, zero fuel weight and fuel on board, gross weight for takeoff over here, cruising altitude, reserve fuel, fuel freezing temperature, and cruising center of gravity. So we have the origin, Lszh airport, Zurich International Airport over here. Destination, Lszh again. So we clear the discontinuity. Runway 14 over here. So we continue. We have the departures and arrivals over here. So we select departure runway and also arrival runway and the seats. So we have runway 14, 10, 16, 28, 32. We select runway 14 in the seats, which is the starter instrument, departure waypoints and fixes. That include also horizontal vertical navigation fixes and altitude and airspeed constraints. We go again in the same plates, departure arrivals. So we can set the approaches now, the arrival. VOM 162834 ILS 14 ILS 16 ILS 28 ILS 34 GLS 14 localizer 28 localizer 34. So we're gonna use ILS 14. Select trans the AMI key, which is a transition, and we set the stars, starter terminal, arrival waypoints and fixes, and horizontal vertical navigation fix and altitude and speed constraints. The negria. So we have the legs here. The route is created but is displayed with blue. It's not yet active. So we have the waypoints. First waypoint after takeoff, the distance from the runway, the altitude. Then make left turn, Zui over here, climb to the negria, 26 nautical miles, then descend, approach Zurich 701 and land. So we have initialized first this, zero fuel weight, 322.7 thousand pounds, fuel on board 34.2 thousand, gross weight 356.9. So we set 5% of reserve fuel, 35,300 over here, cruising altitude, this index over here we insert, and the cost index 100%. Fuel freezing temperature minus 37 degrees, we'll freeze the fuel, cruising altitude. So we can activate now. Press this green switch here, lighted green. It will activate the route with purple and white. So we have the first waypoint, heading 136 degrees, 2 nautical miles, altitude and airspeed. Then we make left turn over here to Zui, 6 nautical miles. We pass through some waypoints, 135 nautical miles, 6 nautical miles Zui, 334 knots, 6,000 altitude above the sea level. Heading 071 is the Negria, 26 nautical miles from Zui, Mach 0.76, airspeed 25,300. Then we make a right turn, descent and approach 12 nautical miles is the Matic, Mach 0.756, make right turn 35,300, 6 nautical miles Amiki, 9 nautical miles Zui. We descend for approach and landing with the Zui, heading to 76 degrees, 180 knots, 7,000 alpha, Zurich 701, 6 nautical miles, 180 knots, 6,000 alpha, TRA, 10 nautical miles, CI 14, 6 nautical miles, Oznem. We make a left turn for alignment with the runway over here at Oznem, and also use the ILS localizer for approach to runway 14 and landing. 8 nautical miles, 1,440 feet. So we use flaps 15 degrees, center of gravity. Over here trim 4.25 degrees, and the takeoff speed V1, rotate V2, gross weight, runway position. So we have also departure, arrival, alternate, VNAV, progress, FMC communication, hold, navigation fix, navigation review. We can tune ILS localizer or VOR. So we use the legs again. Go over here, you see the legs created, the flight plan over here we have to use for flying. So we look closer, we can see more of the flight line, also the runway we use for takeoff and for landing, and the taxiways, the train in front of us. So you can see the taxiways and the runways, also the airport map over here, like in the real aircraft. So we look here outside, you can see the runways and the taxiways we use for takeoff, for landing, the terrain also. So this is for navigation purposes over here only. Also the flight line you see with purple line, also the vertical above the ground as we're gonna be flying. Look further away, more airports. Also we have this view. You can see the aircraft and the runway. can see it says map centering over here, north, east and west. So we look closer over here, we see also the aircraft position, the runway we're gonna use for takeoff. So we use the map again, look further away. You can see more of the flight line, you're gonna see later. So we have also here set up the APU in the on position. We're gonna make an engine start demonstration. We have the IDT 120 200 volts 400 Hz breakers, 120,000 kilovolts left and right engine driving, electric primary flight control computers in the auto, our data computers over here, flight control surfaces, battery, towing power, 50 door, passenger oxygen over here, window heat, rammer turbine backup hydraulics. So we have left and right engine driving. If we turn off, you will see what they display. Primary demand engine driving. We turn back to the on position and then to the auto. We have a couple more things to see. Wing and engine ADIs on or auto position over here. We have also we have the recorders, the cargo and APU fire over here, electronic engine control for the engine, normal and alternate mode, and the auto start controls the FAREX, so we can start the engines like this. We can dump some fuel in flight to lose weight if we arm this and select the nozzles, how much fuel to remain. We have also fuel on board, left and right wing, fuel tanks, and the fuel booster pump, cross-feed valve with electronic feed either engine with other pump, and balance the fuel between the left and right wing. So this is what we need to know. Also we have the air conditioning pressurizer from the engines and from the APU, air conditioning, ventilation, oxygen, and also the pressurization of the aircraft here as we fly. We can use auto or manual. We use the outflow valves to depressurize as we climb or pressurize as we descend the cabin and the aircraft. Depressurize and pressurize. So we have here also other displays. You can see the engines I'll talk to you about now. We have the systems here very quickly over here. So we have hydraulics, the APU is running, oxygen, liquid cooling over here, the electric left and right electric IDG, the drives are connected, the APU is running over here, the battery voltage and the APU battery and charge and discharge of the batteries we need to know. We have the hydraulics over here, where the hydraulic fluid goes, which system use it, primary in demand, set-off valve and isolation, electric C1, C2, also the pressure 5100 psi pressure, and the quality of the hydraulics, fluid tanks. We have the fuel, so we have the left and the right wing, fuel tank, the center tank, the cross-feed valve with the electronic feed either engine with other pump, right the tank or balance the fuel between the left and right wing. We have 11,000, total 33,000 pounds. The minimum fuel temperature below which the fuel will freeze in flight is minus 37 degrees, and the fuel temperature right now minus 6. So we need to recirculate automatically the fuel when we fly. It's recirculated from the FAREX, from the wing tanks into the engines components to heat up the fuel, also the lubricant and the oil. We have the long high pressure fuel valves open from the left and right engine and feed from the center or left and right wing. The fuel booster pumps forward and after the APU is fed from the left wing using the DC motor. So we need to know other things, the air pressurizer, oxygen and air conditioning, cabin pressurization, the doors are closed, the cabin can be pressurized, the gear, temperature of the brakes and pressure of the tires over here, flight controls, we make left and right turns over here, also the tail of the aircraft and the stabilizer. So this is one of the last things we need to know before going into flight. So we go over here, we have FIS display, status, maintenance, circuit breakers over here, and we set up the checklist, normal menu, before start, after start, takeoff, descent, approach, landing. So we have also communications, navigation display again. So we need to restart the engines. We cannot turn off both engines and restart them very quickly. So we use a fuel control valves in the off position. Fuel in the off. You will see what it displays here in the we have the failure of the shutdown of the engines, starvation of the fuel. So we go in here, we look outside. Also we turn on some lights. So we look outside, you can see the aircraft. We have the engines are off right now. We need to restart them very quickly. So we go in here in the overhead panel and restart both engines in the auto start position. You will see the amber reconfiguration switches in the overhead panel. So we go here, we see we have pressurizer right now, and one is increasing, which is the low speed starters have low pressure compressor and turbine with the turbofan to pressurizing the exhaust gas temperature. The N2, which is the high speed starters, have high pressure compressor and turbine of the turbofan to pressurizing. Now we have only these states open, so we have pressurizer from the APU. We need to let the fuel run. So we go back in the fuel valves over here. As you can see, both fuel valves are in the on position like this. So this will turn the fuel flow and the auto start. So we have fuel flow, oil pressure, oil temperature, oil quantity. The N1 also increases more, and the N2. So we are almost for takeoff, 54%. And we have running engines at 61%. We use flaps here for takeoff, like 15 degrees, speed brakes. This arm also fix the autopilot here for after takeoff. We see auto throttle left and right. We can use the LNAV and the VNAV, flight director on and off. So we use LNAV, bank angle, shading over here. We're gonna use shading, same like the runway. Also bank roll automatic. We can use also vertical speed. You will see a minus sign here, or climb positive, or leveling off. So we set also the altitude over here, and hundreds, thousands and hundreds. So we advance the thrust levers, parking brakes off, and use the tiller. We take the air traffic control clearance for this runway. The runway is clear, we have no traffic right now, so we're gonna go for takeoff, and we have so we taxi into the runway position over here, as you can see. So we use the tiller again for alignment. Πας πάλι έξω. So we advance the thrust levers. Σε 20 λεπτά θα έχω τελειώσει από αυτές. For takeoff, and we push the side stick down until 80 knots. We align with the rudder pedals. So we have 80, 90 knots, 100, 110, 120, V1. We pitch up 9 degrees for rotation slightly. So we have V1, we rotate, V2, and we climb, as you can see. You can leave the yoke off or the side stick, no problem. The aircraft keeps fine the way it should be. So we have here all the indications we need to know for flying the aircraft. As you can see, so we are having the airspeed 185 knots, the stall speed yellow and red. We are 2,000 feet above the ground, 2,200, 300, 400, but 4,000 feet above the sea. So you can see the stall speed here, the wind direction and speed, the pitch of the aircraft. And also we climb with 3,400 feet per minute. As you can see, we have also the flight plan here and here. You can see the flight plan, you can see the terrain in front of you and around, also below. So we can use a little bit more indications. The engines also, power over here. So the range, if we increase, you'll see more terrain with red, green, yellow, the mountains, and also the aircraft where it's flying. The flight plan, so we can see now, here we are like 4,000 feet above the ground, over here for 5,000 feet. Keep climbing. You see this green line is 5,000 feet below you is the terrain over here. So we need to start also landing gear up over here. So we have to make the turn now. You can see around the airport, the Switzerland here. So we start turning. If we have time, we will connect the autopilot for display. If we have no time, we'll just make a manual flight, full manual flight. So you can see the airport again in the runways as we depart, using over here the departure. So we look outside, we have this beautiful view here as we're flying. Hope you like it. The Switzerland view and now also the galactic view over here. The Boeing 787. So this is the most beautiful view you can have here in this place. Make a small turn over here. We follow all the air data for this flight. So this is the most beautiful view you can have over here. The Switzerland, the lakes, the Swiss Alps, also the Germany, my homeland over here. In front of you now the France. We have the France on this side. So we make a small turn, align with the flight plan as we fly, and we have 12 more minutes to go back into the airport. So you can see a view of the aircraft after takeoff, the overhead panel, how it looks. There's normal everything, also the cockpit. We need to align with this flight plan line over here. We have the air data, also the airspeed 170 knots, the stall speed here 125 knots, the wind direction, this vector 24 knots, and also the waypoints we need to fly through. Over here the flight plan, you can see plan, other indications. So we align here with the flight plan. You can see also the other both sides of the flight plan over here. We need to follow through. All your data, the autopilot right now. Finding. Have a few more minutes. So here we are, we have the France in this side, my homeland Germany in front of you. Also the Switzerland, this side, the Swiss Alps. So we keep flying manually. We cross through 20,000 feet. Maybe we have not much time left to connect the autopilot. It will delay us a lot. So we make the turn now and keep flying manually. We make a manual turn over here. Also the flight plan. So this is how to make a manual turn over here. 31,000 feet over flying this place. So you see we're overflying Germany over here, the lakes, the Bayern Munich over here, this side, the aircraft. The France over side here. So we're flying smoothly over here manually. We use a little bit right rudder to align with the rudder also with this heading without the autopilot need. You can do fully manually, as you can see, with the side stick, no problem. Either other flight, the previous flight I did with the autopilot. So you see I make one flight with autopilot, one flight manually. So you see that there is a small difference. So we balance over here. We need to align now with the flight plan again as we fly. So we are at 33,000 feet. Also we have the chemtrails here, beautiful chemtrails as we fly. You can see these frozen vapors. We are almost 8,000 meters above the sea level. So we are overflying Germany, France over here, Switzerland. The frozen vapors, the exhaust from the engines. Also this is very beautiful galactic view over here. Very beautiful view over here. We're leveling off, as you can see. So we start descent now, back to the airport, flaps retracted over here, and also speed brakes extended. increase the rate of descent. Spoilers. So we put the yoke down and follow this flight plan we have created. We have 6 more minutes. We use a little bit more thrust over here as we descend. So it's better to have a little bit more time. You see the blinking runway lights over here as we descend. Also the cockpit inside. So hope you like the following we do. You can see the flight plan we have to follow. Also I use the yoke slightly. So we are 18,000 feet, our airspeed 300 knots or Mach 0.649. We have the autopilot also settings preset if we need to engage the autopilot. The engines thrust is a little bit high right now. It's almost 63% of N1. So we need to decrease a little bit as we descend, increase the rate of descent like this. So we're gonna use a little bit idle thrust, also align with the flight plan, both sides. This is also the head-up display. We need to align with the flight plan again, as you can see. So we use also this flight plan here. So now we are aligned with the flight plan as we descend. And we have 4 more minutes for approach and landing. We need to enter the pattern. You can see ZX701 is the next waypoint we have to follow. So we make a turn now as we're descending. And we have 3 more minutes for approach and landing over here. Use a little bit more thrust for the descent. So use a little bit less thrust and also increase the rate of descent over here. Flying manually. So turn again, make left turn again. Use left rudder also to align with the runway as we descend. So we are descending, we need to align with the runway heading over here as we descend. So we have the runway in front of us, we need to be aligned now. A steep alignment. Maneuver like this. Also reduce the airspeed a little bit. So we have a few more minutes to go. We need to use a little bit thrust over here as we descend and a little bit more flaps. We're gonna have also the outside view as we descend for approach and landing over here. Landing gear down also. Flaps also. Flaps for landing. So we approach for landing like this manually As you can see, we have 1 more minute. There's a little bit more airspeed, more thrust. So you can see we have also the ILS localizer here. The indications we need to follow for approach and landing. And we have a few more seconds left before the video will end. We have some side wing and wing gust over here. We need to align with the runway as we are approaching for landing. And we have 40 more seconds for the record of the video to end as we are approaching for landing over here. So we need to align with the runway, use all our flight controls that we can. We're gonna have the flare in a couple of seconds over here. So flare here, very beautiful touchdown, parking brakes, idle thrust, and thrust reverse, full thrust reverse over here, align with the runway, and full thrust reverse